we do have the components. So if you do have the component, you must use them. And you cannot use just simply find a specific gravity and use these graphs, because this brings more inaccuracy in your calculation. But in case you don't have anything, you don't have the components of a gas mixture, and the information you have the specific gravity, then you can use these two graphs to come up with the TPC and PPCs, use the total pressure and temperature of a system to find the TPR, PPR, find the Z factor, and find the properties of the gas, okay? If you don't have the components, okay? In addition to the heptane plus, which wasn't a pure component, that you should be able to find the TPR, the pseudocritical temperature and pseudocritical pressure from figure 310. In some cases, you might also have non-hydrocarbon components, okay, like H2S or Cu2 or nitrogen, okay. H2S is very critical, okay, because it hugely impacts the value of your gas, and it makes the refinery very difficult, and all the problems. So it's very critical. You also might have some CO2 in the system. So for this calculations, this H2S and CO2 can significantly can affect your Z factor calculations. So if we do have H2S and CO2 in our system, at the end when we find our TPC and PPCs, the critical temperature and pressures, before we use that to find our reduced pressure and reduced temperatures, we need to do the correction. We need to perform the corrections for non-hydrocarbon components. The correction is in terms of the temperature, okay? So when we find the TPC, exactly the same way that we discussed, for all these pure components like H2S, CO2, nitrogen, the properties are given at the end of the book. If you have heptane plus, you can find it from figure 310. Mole fractions times critical temperature, sum them up, that's your TPC, okay? But if you do have H2S and CO2, that TPC needs to be corrected. And the correction is through a correction factor, which has a temperature dimension, we call it epsilon. So this comes from figure 312. Remember, in figure 312, the x and y axis is based on the percentage, mole percent. So if you have 0.01 mole fraction of H2S, that's 1%. If you have 0.1 mole fraction of H2S, that's 10%. Okay, just make sure that these are based on the percentage. You need to multiply the mole fraction by 100. And if you have, let's say, 10% of H2S, so the x-axis is H2S, and 5% of CO2, so the y-axis is CO2, then this is 10%, this is 5%, and your point is very close to this curve with a value of 20-degree Rankine. Okay, so we locate the point, and then we see which one of these curves are going through that point, or we pick the one, or we do the interpolation between the two curve. So if my point falls somewhere here, if I have, let's say, 20% H2S and 20% CO2, then my point is here. So it's between, this is 30. For this one, I don't have, for these two, I don't have the numbers. Let's say if it's like 10% and 20%. So the point is here. So it's 26, 27, 28. So it's between 28 to 29 degree Rankine. So I can rate that as 28.5. Okay. So the CO2 percentage, the H2S percentage, and then wherever the point falls, then I have these numbers like 5%, 10%, 15%, 20%, 25 degree Rankine, 10, 15, 20, and 25 degree Rankine. So I have these numbers. If it falls right on the curve, I rate that value. If it falls between two of these, then I do the interpolation. Okay. So I find the correction. If I find the correction, I can correct the TPC by simply subtracting the correction from the pseudocritical temperature, and when I get the corrected pseudocritical temperature, I use the corrected pseudocritical temperature, the uncorrected pseudocritical pressure, uncorrected pseudocritical temperature, the mole fraction of H2S, and the correction factor to correct my pressure. So I can use this equation to correct my pressure, use this equation, correct my temperature, and then I'm going to use the corrected TPC and PPCs to find the pseudo-reduced temperature and pressures. And then after that, I use that for my calculations. So this example is nice In a sense, it has all the critical temperature and pressures of the pure components. So if in any example, homework, quiz, or exam, you need the critical temperature and pressure of the pure components, you can simply refer to this table. You don't even need to go to the end of the book and read them because these are constant numbers, except the C7 plus. As we said, the C7 plus is not a pure component, so its property is not tabulated at the end of the book. This number can come from the critical temperature and critical pressure of heptane plus can come from figure 310, knowing the specific gravity and the molecular weight. And we know the specific gravity and molecular weight of the heptane plus will change because different mixture will have different components heavier than heptane. So these numbers would change, and as these numbers will change, the critical temperature and pressure will change. So except these two numbers, the rest of the critical temperature and pressures in this table can be used for any example because these are fixed numbers. So in this example, the question is to find the pseudo-critical temperature and pressure. It could be to find the density of a mixture at a given pressure and temperature, or specific volume of this mixture at any given pressure and temperature, or mass of this mixture at any given pressure and temperature. So this could be one of your, this will actually one of your open book questions for the midterm. So I'll give you a mixture very similar to this. You will have the H2S and CO2, like non-hydrocarbon components, some pure components, like two components like C2 and C4 or C1 and C6, and then you will have the heptane plus. So I'll include the non-hydrocarbon components, I include the heptane plus, and I include some pure components. And I'll ask you to find some property of this mixture given their mole fractions. So if the mole fractions are given, you use the critical temperature given here, critical pressure given here. For heptane plus, I'll also give you the heptane plus specific volume, specific gravity, and the molecular weight. You use the specific gravity and molecular weight of heptane plus in figure 310 to come up with critical temperature and pressure of the heptane plus. When you have that, the mole fractions are given, the critical temperature and pressures are given. You multiply mole fractions by critical temperatures, mole fraction by critical pressure, you sum them up, and you will get the pseudo-critical temperature and pressure. For example, here you have 506 and 707 for pseudo-critical temperature and pressures. Then you need to find the correction because you have non-hydrocarbon components. Remember, in figure 311, the mole fractions are in percentage. So H2S is actually 4.9% and CO2 is 11%. So for almost 5% H2S, 11% CO2. So I go here, almost 5% H2S, so this is 5%, and 11% CO2. So this is 10 and 11, 11 and 5. So your point would be very close to 20-degree Rankine for the correction. So the actual number is 19.9-degree Rankine. So when I have the correction factor, I subtract that from my TPC to get the corrected TPC, and then I use that equation to find the corrected PPC. Now that I have the corrected TPC and corrected PPC, if I want to find, let's say, the Z factor, then I need to find the TPR and PPR, the pseudo-reduced temperature, which was the actual temperature divided by TPC, and actual pressure divided by corrected PPC. And then if I have TPR and PPR, I can read the Z value from the Z chart and do any calculations using the real gas equation of state, okay, which is PV equal to Z and RT. So this is very important. So what you can do, you can add a couple of assumptions here. You can say, hey, find the density of this mixture at, let's say, 4,000 psi and 100 degree Fahrenheit given the mixture. So if you can solve this, then definitely you will be able to solve one of your open book questions for your midterm exam. Okay. This is the last slide for our chapter 3, and we follow with our chapter number 4. Okay. And again, if you have any question or concern regarding any parts, just make sure that you write the slide number and then with your question, email it to me. We'll have our meeting. I'll try to reply to you with the email. But if you want to see me and then discuss over the slides, we have our office hours that you can send me an email. I will schedule that and we will meet.